Is it a function? We're going to use mapping diagrams, ordered pairs, and vertical line tests for graphs to determine whether or not a relation is a function. Let's start with a few examples of mapping diagrams. So here's an example. We have the numbers 1, 2, 3 as our inputs, the domain on the left, mapping to the outputs or range of 5 and 7 on the right. Now, just as a reminder, a relation is called a function if for each input or number or value in the domain, we get exactly one output in the range. So let's look at what's happening in this mapping diagram. If we put the number 1 into the relationship, we know that 5 will come out. If we put the number 2, we know that 7 will come out. And if we put the number 3, we know that 7 again will come out. So yes, this is a function. It is very clear for each element of the domain, we can be confident. We know exactly what output we will get in the range. Let's do a second example. So we have another mapping diagram where we have the numbers 1, 2, 3 as our input or our domain, and the numbers 5, 7, and 9 as our output or our range. So remember, for each input, for each element in the domain, we have to know that there is exactly one output in the range. So let's take a look at it. Look at number 1. If I have number 1, what output will I get in the range? Well, this is already, we can see a problem. Either 1 will give us 5 or 1 will give us 7. We're not sure. Because we have this situation, a picture like this, you have an input giving us 2 different outputs, that is the problem. So in this case, this relationship, we would say, no. This relation is not a function. There is an input that actually could give us 2 different outputs. So it's not a function. Okay, sometimes we have relations and they're not shown to us as mapping diagrams, but instead they're shown to us as sets of ordered pairs. So let's look at these examples. I have 4 different examples here. We can call them A, B, C, and D. Let's look one at a time. Now, there's many ways you can look at this. For me, sometimes I like to actually just take the set of ordered pairs. These are the different inputs and outputs, X, Y, and so on. The inputs, the outputs, and actually go ahead and list it as a mapping diagram. So for example, 2 would go with -3. 3 is also going to go with -3. 1 goes with 4. And in this case, 9 goes with 2. There's your domain or your inputs. There's your range and your outputs. And the question is, and I'll put that definition of a function up again, we need to know that every input or every element in the domain goes to exactly one output. So if you look at the mapping diagram here, you see we know exactly where 2 is going. We know exactly where 3 is going, exactly where 1 is going, exactly where 9 is going. There's no question. Each input has exactly one output. So in this case, yes, it is a function. Now, a shortcut way of looking at it is in the list of ordered pairs is this. Look at each input. Each input is different. So we know we're not going to run into a problem. We only run into a problem where you have an input giving you 2 different outputs. So you'd have to have 2 different points with the same input giving us different outputs. So you can use the mapping diagram, switch it into a mapping diagram, or you can just go ahead and look at the inputs, 8, 3, 9, and -2. These are all different inputs, so I know I will not run into a problem of an input giving me 2 different outputs. Why? Because each input is a different number, so you won't have any conflicts. Let's look at the next example. 1, 4, 9, and 3. Again, same issue here is each input is different. So I know I won't have any contradictions of the same input giving different outputs. Let's look at the last example. 1 minus 1, 1. Uh-oh. I might have a problem here. Let's double check by making a mapping diagram. So 1 maps with minus 1 in the range. An input of minus 1 maps with 5. Wait, I have another 1 here. So this 1, it could also possibly give you an output of minus 6. And then for the last point, 3 goes with 2. Well, I see a problem. And the problem is here. If I have an input of 1 and I ask you to tell me what's the output, you won't know. I have two choices. Either the input of 1 goes with minus 1 or with minus 6. And this is a problem. You are not allowed to have one input giving you two different outputs. So in this example, we say not a function here. So when you have a mapping diagram, if you want to shortcut it, just look and make sure that all the inputs are different. Sorry, when you have ordered pairs. If you have ordered pairs, if all the inputs are different, then quickly you can say it's a function. If you have inputs that are the same and they are going to two different outputs, you can directly say, no, it's not a function. Okay, the last way we can see relations is through graphs. So here are 3 different graphs, and there's a way quickly to decide whether each graph is a function or not. We can use something called the vertical line test. So what the vertical line test says is if you hold up your pencil vertically, like straight up and down, and move it across the graph from left to right, as long as it only touches the graph in one point at a time, then yes, it is a function. So imagine I'm holding up my pencil in front of graph 1, and I quickly move it from left to right across this graph. At any time, that vertical line is only crossing the graph at one point. So in this case, you would say yes. Okay, let's look at the second graph. It's just points that are not connected, but that's fine. We still move our vertical line from left to right across the points. And at any given time, every vertical line that intersects is only intersecting one point at a time. So again, I would say yes, it is a function. Well, now let's look at this third graph. I hold my pencil vertically up and down. I start moving across the graph from left to right, and already I see a problem. This vertical line is hitting the graph in 2 different places at the same time. What that means is there's this x value or many x values that give us 2 different y values, which, as we remember from mapping diagrams, this is not allowed. So in this case, because the vertical line would hit the graph in 2 points at the same time, we say no, this graph is not a function. Okay, I'll minimize those, put them off in the corner. Let's try 3 more examples just to make sure we've got the idea. Okay, let's look at graph number 4. It looks a little bit strange. It's sort of pieced together, but that's fine. We'll still take our vertical line, start moving left to right. Now this might look like a troubled area, but if you'll notice, one of the points is colored in, one is open. That means only one point really exists there, so still we're fine. Again, we're still only touching the graph at one point at a time, so we'll say yes, this is a function. Okay, the next graph, we take our vertical line, we start moving left to right, and already we see big problems. We see for the same x, we see 2 different y's. So we say no, it is not a function. Okay, One more time, we've just got points, but we'll still move left to right. And I see no problem except until I get here. For that same x value, I see the vertical line hitting two different y's at the same time, which is not allowed. You cannot have one input giving two different outputs. So we'll say, no, this is not a function. Okay, so 3 different types of visualizing relations and 3 different methods for determining if they are functions or not.